Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about the expression result and take their statistics estimation. We will find the statistics of the catalog information of every join relation, selection relation, sorting relation, and check what is the statistics of each of this result on the expression. First, we will check about the catalog information. For the catalog information to build on a statistics, we first need to look at the expression on a relational algebra and then find what are the procedures or what are the values on which we can build the statistic. Now for the catalog, we will need the following terminologies. Now the VAR represents the distinct values of attributes A in relation R. So it is same like if we projection of A on R. That means that are the values of a particular attribute over a relation. Now we can say that for this derivation of BR, NR and FR, we can have the number of blocks equals to total number of tuples divided by the number of the blocking factor. So the BR equals to NR by FR. And also the BB refers to the buffer block size that we need in our catalog information. Now how to build on this information a statistics out of the data? We can either use a histogram to it. Histogram means that a range will be represented as a rectangle which will represent the certain value in the data. So it can be a width-wise representation of histogram or a breadth-wise representation of histogram. The width-wise representation tells us about that for each width, what is the data on a certain basis. Now we can calculate the BR of each of the relation and say that what are the number of blocks that varies between the relation to relation. The lengthwise representation of histogram somewhere accepts an average of the data which ranges similar to each other and then put this range as the particular range to see that how many relations on this range belongs. That it takes the blocking factor as the range and the y-axis will give us number of ranges or number of relations in that range. Now say suppose I want to group like for 9 people's a data and the range will be from 0 to 10, 10 to 20 like this. So how can we use this histogram? So for each of this range we will have an histogram. Say for the number of students and we can have the number of students belonging to this age group. So from 1 to 5 age group we can say that there is a histogram representing a rectangle. Now from 6 to 10, it's somewhere lying around 25. So we are actually giving the representations of BR along with it. For 11 to 25 group, it is 22. For 16 to 30, it is 39. For 30 to 35, say it is 15. So these are the NRs, these are the FRs, and these are the BRs that we are plotting against it. So now this way we can use this width-wise histogram to see that the number of blocks in each of the relations in a database and to calculate the catalog information on the heuristics. That means when we find the catalog of a product that gives the overview of the product. So also this histogram will give us the overview of a database and the relational relationship among the tables. Next is the selection size estimation. Selection size estimation means if we belong to that a particular value ranges with the particular value. That means it can be a greater than less than comparison or it can be an equals to value. So first we will start with an equal value that will select only one record. Say we are finding the course IDs or the department music's course IDs. So now we can have NR divided by VAR number of tuples in this one because this will generate a selection of attribute A having a particular value small a. So if the course ID and the text relation we are talking about, Then the course ID that matches with the text, that means the course ID that is belonging to each of the student. Now, in this assumption that we have taken that a particular value is being matched and then we are selecting the tuple against it, is false if the text relation has the course ID duplicated to it. So for a reputed college, it is always possible that a student has taken many course ID or one course ID has been taken by many students. So for each of the student that takes course ID will be repeated. So there we cannot have this A equals to A assumption on the selection size statistics on the data. So that the graduate department statistics will be different from the undergraduate statistics. So we cannot select on the size of these tuples so that we can have the estimated result on it. So now this course ID text relationship doesn't just vary on this assumption, but also it relies on the degree of certain conditions, not the value of a particular attribute. Now the next one is the less than relationship. Now this relationship suggests for the cost estimation of A less than B. Now when we have A less than B, that means it will happen A less than 0 if B is less than the minimum of small a and R. That means A has a minimum of value A belonging to the relation R and B is less than this minimum. That means there is no such value that exists in the relation that is less than B for an attribute A. Now, how can we calculate the cost of it? It can be calculated like, so there will be inner number of tuples in the relation that is multiplied by the V minus minimum of air. That means, say, suppose the attribute A is salary, we are finding on a 75,000 range and the minimum range is 50,000. So we can have the range of the salary between this 50,000 to 75,000. That means this 75 minus 50, that is 25,000, and the maximum salary is 1 lakh minus 50, that is 50,000. So 25 by 50, that is 0.5% of inner can belongs to this A less than B category if it is on the salary basis of 50,000, 75,000 and 1 lakh. So now we can have the estimation on this particular formula that if V belongs to the minimum of R and the maximum of R, then it should have a 0.5% belonging to the range. Now my V is 90,000. That I am finding any salary that is less than 90,000. So what happened? It becomes V minus 90,000. So V is 90. The lesser memory or the minimum salary is the 50,000. So my deficiency is 40,000. And also the range is 1 lakh minus 50,000, that is 50,000. So it is 4 by 5. That is nearly around 0.80%. So now we can say that 80% is the chance of having the salary if it is less than 90,000, and if it is 75,000 then it will be 0.5%. So building a statistics over the comparison, that is the selection predicate with the size we are mattering on. Now, if a histogram is available, then we can see more accurate result other than just predicting 0.5%. Say for an example that there is only one instructor who has been paid 75,000 salary, that we are taking a 0.5, that is 50% of total instructors. If there are 11 instructors and only one instructor being the particular range of less than 75,000. Now the other are belonging to the 75 to 1 lakh thousand. So how can we represent it? We can represent an histogram with each of the salary or at least a range of the salary so that we can give an accurate view of which is the number of salary or what is the better prediction on it. Now the next one is selection over a complex operation. The first one is the conjunction. Now if each of these theta I selectivity on relation R is represented by SI, that means SI represents the selectivity of theta I of R, that is the size. So we can say that we are the probability having of selectivity SI by Ni. That is for each theta I there is probability of SI by Ni. Say for the first one it is S1, among this Ni say 5. So S1 by 5, S2 by 5, S3 by 5, like in this. So whenever we are talking about conjunction, that means the intersection. So when we will take this intersection, that means only the part of it that common to both of this prediction. See, suppose I want the salary on the instructor who has been the salary greater than 50,000, city equals to Mumbai. So we will first calculate the probability of city equals to Mumbai, then the salary greater than 50,000, then combine this both. So what is the final probability of having it? Is S1 by n divided by S2 by n multiplied by Sn by nn, like this one. So now we can have the probability of all the multiplied products of the predicates divided by the total number of tuples, that is total number of tuples. So we can have at most nr to the power n minus 1 or 1 minus n with this S1 multiplied by S2 multiplied by Sn. So this is the conjunctive selection probability on a statistics. Now let us calculate for the disjunction. So if this is this conjunctive on the disjunctive selection, then we can say that Si by Nr be the probability of selection over theta I selectivity. So now if this is the theta I selectivity, then Si by Nr is the theta I selectivity of each of this conjunction and disjunction. So for the disjunction, we have 1 minus Si by Nr. That means the one that doesn't belongs to this group will be associated with the another group. Say suppose I want the instructor names who lives in city Mumbai or is salary greater than 50,000. So we will take all the salaries who's greater than 50,000 even if they are not in the city of Mumbai, and also they live in city Mumbai even if their salary is lesser than 50,000. So now that one I make the choice of 1 minus Si by Nr. So now my total probability of having a disjunctive selection will be, so it will be 1 minus total of this. That means the first one will be taken as the probability with all other probabilities that it is not there. That is city of Mumbai with 50,000 and also that are not in 50,000. So like this we can calculate all the probability of a disjunctive selection. Finally, the last one is negation. What does the negation stands for? That is, it doesn't belong to the predicate. So it will be same like the predicate whose values doesn't belong to this theta. So it is more like an unknown because the theta and we do not know any other selection on the predicate that is not equals to theta. So it actually the reverses of Si by Nr, that is 1 minus Si by Nr for the negation. So if it is the negation, then we can say that we are having 1 minus Si by Nr, where this Si by Nr is the probability of having selection of a negation of theta. Now we will talk about the joint order probability on the statistics. Now if LR is belong the size of the tuple of a relation R and we are taking a cross product of relation R and S, so it will generate NR into NS number of tuples to it. Of each of the size will be LR plus LS. Now if the first one, this R intersection S is equals to theta, that means that belongs to any of the intersection that doesn't happen in both of the relation. So it will not have any relational in this case. Now if R intersection S is not equals to theta and we are performing R join S, that means R cross multiplying S or an cross product of R and S. The size of the joining, if this is intersection not equals to null, will be same as the Cartesian product of these two. Now if R intersection S have a key of R, now what happened that the primary key of R is the primary key of R intersection S. If this belongs, then we can say that R join S implies R cross product S, but the probability of having it as the number of tuples in S. Why? Because R is the key and for the key every tuple will be attached with from this S. So R is the key and we can have at most number of tuples of S in this R cross S or R Cartesian product of S as the joining of this R and S. Now what happens if the list scenario, that is the R intersection S, has no key from R and S both? Now if we estimate a tuple T over the relation that is R and S, and we have the R intersection S as a set of attribute A, then we can estimate it as NR by VA comma R for the each of this R and S. As a product, it will have NR into NS by VAR into VAS. If there is no key that is belonging to R or S, belonging to this R intersection S. Now, if it is in the R, then we can say that we are having NR by VAR. If it is in the S, then we are having NR by VAS. Now, if it is R intersection S, then we are having this one. Now, what happens that if it is R unioning S, then it will have, so if it is NR into NS by VAR for the relation R, if it is in the left side, and if S is in the left side, then it will be NR into NS by VAS. Now let us see an example to join this theta on R and S as the student and text relationship. So if NS equals to 50,000 and FS equals to 50, then we can calculate that BS equals to NS by FS, which is equals to 100. And now N of this text equals to 10,000 and F text equals to 25. So my BT will be 400. Now if we calculate the VID on text, that is a particular value ID that belongs to the text relationship, so we can have 2500 as a result. Now we will calculate the following. Now we will calculate the size of student and joining text without any information on the foreign key. First we have the VID text as 2500. So here we are calculating the NR into NS VID text because text belongs to this right side. So now it can be calculated from 5,000 into 10,000 divided by 2500 to result in 20,000. Now if one more relation is there, that is VID student, which is equals to 5,000. That means it is giving us a reference that the student and half of the student has taken the some courses, because the ID both of the student and text are same because student is taking a course. So 5,000 student is there, but only 2500 text with the ID matches with the student. That means there are 2500 students, or half of the students has taken some courses. Now how to calculate this one? We can either just divide it by 5,000, or from this relation we can say that it is 2000 by 2 or equals to 10,000. Now using this only the value represented are NR, NS, NT, FT, we can calculate the size of the student joining text. Now we will calculate the size estimation for other operations like the projection, aggregation and all. Now for the projection, you will say that projection of A on a relation R is equals to this VA of R. That means the size estimation of a particular attribute is the value of that attribute within the relation. Here we are talking about the unique or distinct values of that attribute. Now the aggregation of a particular attribute is also the value of that attribute, that is the size, because on the value of the attribute the aggregation can be calculated. Now the set operations like the union, intersection and difference stands for if there is any union, then it will go for the summation of R and S. If there is any intersection, then it will take either the size of R or S. And if there is any difference, then it will take the size of R, because R is all the relation that we are having, not within this S. Next is the outer join. We will take the full outer join for our consideration. If it is full outer join, then we have all the relations from R and S explicitly has a relation from the R and also from S. So it will be the size of R join S plus the size of R and S both. Now how will we calculate the size of an individual distinct number? Now, if it is a selection on a particular number, then obviously it will be 1. Say for an example, we are selecting an attribute on the ID that is A01. So it will select only one. So the size of such distinct number will be 1. Now, if it is a conjunction or disjunction of a particular value or a range of values, then it will be all the set of the values that the result set all the size. So now, if it is, then it will be the set of 1, 3, and 4. So if it is ranging on some specific values or it is in a comparison range, then it will contain the range or the values, that is the set on the size of that particular value. Now, if the selection of a particular attribute is a selection of a particular tuple, say for I want the execution or the selection over a particular value of an attribute along with the tuple that is present in that relation. So it must belong to the tuple and that tuple should consist the attribute value to 1. So we can have it as var, comma, n theta r. That means on the particular tuple nr, we are having the relation and also with the value. Then it will be the joint set on which the tuples are forming for plus the r, because r is the one that we want to intend the tuple. Now, if all the attributes from R, that means the resultant of a join, we are having all the attributes that are and S are the duplicated values or some referred values. Then we can have the set or the size of that particular selection to the minimum of the selection. That means if A belongs to R only, so now we can have the minimum of this joining along with the all relation from this S. Now it also is true for the S also. That means the right side relation and the left side relation both will have this one. If some relational attribute belongs to only a particular relation, then we take the relational join and the attribute from the other relation as the size. Because the attribute set A is already belonging to relation R. So we need to consider the attribute from S along with the joined attributes. Now suppose that a set of attribute A contains A1 attribute set from R and A2's attribute set from S, then we have the probability on the size of selection as, so now we have the minimum from A1 R and A2 S also with the set that is A1 minus A2 for R, that is R is having A1, so we are set differencing it with A2, and S is having A2, so we are set differencing that with A1. So we have only the attributes from R, only the attributes from S, and now that we have joined them to find our final production and R and S joining. So in this way, we can select the size of a particular projection and selection over the set of differentiation operator, union operator, intersection operator, attributing operator belonging to each of the different sets or relation. So that is all for the estimation on an expression result of the selection, complex operation, join operation, numbers, arithmetic operation and all. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.